Welcome to Maths for You YouTube channel. A past question on differential equation is an Oxford and Cambridge past question. A scientist is attempting to model the number of insects n present in a colony at time t weeks. When t equals 0, there are 400 insects, and when t equals 1, there are 440 insects. Part 1. The scientists assume that the rate of increase of the number of insects is inversely proportional to the number of insect present at that time. So that the rate of change of the insect is n dn over dt is inversely proportional to n. That's what it is. So write down a differential equation to model this situation. So in order to model first, n equal 400 when t equals 0, n equal 440 when t equal 1. This must be is the rate of change with the time. Therefore n must be in terms of t, but we don't need to worry about it. We can find out. So what further information given, the rate of change always, just the dn over dt, if it's whatever the rate of change. This is here the rate of change of n, so dn over dt inversely proportional. That means proportional to 1 over n. To make it the proportional equation to conventional equation, we have to multiply by a constant. So dn over dt equal k over n. K is a constant, which we need to find it later on. Right, if you could cross multiply n times dn and k times dt, n times dn equal k times dt. If you integrate, we could remove that. We can get n. So n integral of n with respect to n squared over 2. K with respect to t, kt, and plus c. It's an integral constant which we have to consider. So if we rearrange it, n squared multiply by 2 to the right hand side, 2kt plus 2c. So we know nt equals 0 is 400. So that should satisfy this n equation or n squared equation. So we can substitute n equals 400 and t equals 0. If you do that, the n squared is 400 squared and t is 0, so the first part is 0, 2c left it. So 2c is 400 squared. So now we can write the equation again. N squared equal 2kt plus 400 squared. Just keep that 400 squared as it is. Right, now we need to eliminate k, so we need to find the value of k. But we have another information, n equal 440 when t equal 1. So substitute that, 440 squared, kt times 1, t is 1, plus 400 squared. So from that, if you could take, rearranging it, 2k, 1 times 1 is 2k, and the 440 squared is 400 squared. This is same as a squared minus b squared. So therefore 2k equal a plus b minus a minus b. So 440 plus 400 times 440 minus 400. 440 plus 400 is 840. 440 minus 400 is 40. So 2k is 840 times 40. So n squared, we know that is 2kt. So n squared, 2k is 840 times 2, and t times t plus 400 squared. So n equal square root of the whole lot, 840 times 40t plus 400 squared. Just leave it like that. They haven't asked us to simplify it, but just want the equation for n in terms of t, which we have. So that done. Solve the differential equation to find n in t. That's done. So b part done. Second part, In a revised model, it is assumed that dn over dt equal n squared over 3988 e to the power of 0.2t. Solve this differential equation to find n in terms of t. So we have given the differential equation. So that is what dn over dt equal n squared over 3988 e to the power minus 2t. So again, separate the variable, so keep the n one side, t the other side. So t dn over n squared equal dt over 3988 e to the power 0.2t. If I could sort of bring that 39 to left hand side, just multiply it, it's just a constant, keep it to the left. So 3988 integral d n over n squared, that will be n to the power minus 2 dn, and the right hand side dt, and again it's e to the power of 0.2, 1 over e to the power of 0.2t will become e to the power of minus 0.2t dt. So having got that, we should integrate to get n. If you do integrate that, so this side, the integral of n to the power of minus 2, n to the power of minus 1 divided by minus 1. So that is what I put minus in front, so I just jumping one step. So minus 1, 3988. Again, n to the power minus 1 is 1 over n. Again, this one is e to the power minus 0.2t, and differentiation of minus 0.2t is minus 0.2. That is, we have to divide. So that is minus 0.2 plus c. The constant, integral constant c, integral constant. Right, so a bit more simplification. We have a minus on the left hand side, a minus on the right hand side, just ignore that minus. 3988 over n equal 1 over 0.2 e to the power of minus 0.2t minus, yeah, because of we took minus here, so minus plus divided by minus is minus c. 1 over 0.2t is 5 e to the power of minus 2t minus 0.2t minus c. So again, we know that when t equal n equal 400. So substitute that 3988 over 400, n equal 400, and t is 0. Therefore, e to the power of 0 is 1, only 5 minus c. From that, c, we can find c. C is 5 minus 3988 over 400. Use a bit of calculation, calculator work. The answer was this minus 4.97 c found. Right, now 3988 over n equal 5 e to the power of minus 0.2t. Instead of c, instead of this minus c there, we put that minus 4.97, so that become plus 4.97. So what I did here, it just cross multiply. So just n go to the right hand side, and whatever on the right hand side coming as a denominator. So n equal 3988, 5 e to the power minus 0.2t plus 4.97, n equal square root of the n equal, yeah, all right, sorry, that's what it is, n we found. So we need to go for this the next question. Yeah, that's in terms of n, in terms of t, that's done. Sorry, I just kept going. Compare the long-term behavior of the two models. So we have found two ends, I mean two different ends through different assumption. So the first assumption is the rate of change is proportional, inversely proportional. From that we found this equation. So we could write that equation here for us. So n equals square root of at here. That's equation. That's I'd say, yeah, it's worked out. Here, this is n equal square root of 840 times 40t. That I have written it again is here. And then again, next equation we just found is n equal 3988 over 5e to the power minus 0.2t plus 4.97. There are 2t. But they say long term in mathematical term here is t in tends to infinity, t bigger and bigger, so it tends to infinity. If we apply, if we substitute infinity for t on that first equation, it will be sort of 840 times 40 infinity. The whole thing will be infinity. Therefore, n tends to infinite value. Again, if you look at infinity for the second one, where we have it, e to the power of minus 0.2 infinity, that is 1 over a big number is 0. So that's 0. What we have left with 3988 divided by 4.97. That is roughly about 802.4. We are talking about the number of insects, so it has to be an integer. So that's 802. So the first assumption, it's increasing to infinity number of insects, but the second one, it's actually come to 802. What's happening is the rate of change is, if you look at it, rate of change, it's just a rate of change is it's decreasing it. So therefore, we come to 802, increase and then reduced again. So the first assumption is infinite insects. Second assumption is a finite value, is 802. Thank you. Please subscribe the channel and share the contents with other students and friends. And as I said before, please send some questions via comments, and I will make more videos on them. Thank you.